So in this particular problem, it asks us to determine the instantaneous speed of the 60 kilogram block A if the two blocks are released from rest and the 40 kilogram block B moves 2 meters up the incline. That's just the coefficient kinetic friction between both blocks and the inclined plane is 0.1. Alright, so let's show you how to attack these types of pulley system. Okay. So here we have block A and then we have block B. It says that block B is going to move up the ramp 2 meters, which would suggest that block A over here is going to move down the ramp. The one thing I do want to point out and caution you is that for this type of system, the acceleration for both blocks are not the same. Okay, they are not the same just based on how it's hooked up. If you set this up in the real world, block A will accelerate slower, block B will accelerate faster. Block B, as a matter of fact, will accelerate twice as fast. Okay, it accelerates twice as fast because in the real setup, if you were to measure the distance, block B, if it were to move up a distance of 2 meters, as stated here, you'll see that block A will actually only move down 1 meter. Because they move for the same amount of time, well, to cover twice the distance in the same amount of time, this block B will have to accelerate twice as fast as block A. Okay, so keep that in mind as you follow along the work here. So it's important that you just be able to look at it and identify which block moves faster and which blocks, when I say move, I'm talking which block accelerates faster and which block accelerates slower. So block B in this particular problem will accelerate faster than block A. Alright, so I'm going to draw my free body diagram. Here's f of GA. Pointing down the page, block A is on a ramp, so therefore it has to have components. F of GA here has a component in the y direction, and then F of GA also has a component in the horizontal direction. The horizontal direction or x direction taken to be the surface of the ramp. So if you haven't done any incline problem, and if this is your first one, it's important to keep in mind that the x-axis is along the surface of the ramp, and then perpendicular to the x-axis would be your y. Okay. So I'm going to label the 60 degrees here. The 60 degrees is the same as the angle of the ramp. So the angle that touches f of g and f of gy, in this case f of ga and f of gay, is also the same angle as the ramp. So I'm just going to label this FGAY is mg cosine theta. FGAY is cosine because this is the leg that touches the hypotenuse and the angle. Okay, so this is your adjacent referencing the 60-degree angle. Because excuse me. And then the other components, f of gax. F of gax always points down the ramp. In this case, it is the opposite leg of the 60-degree angle, so it would be sine, so it would be mg sine of 60 degrees. Okay. And then also what's acting on block A is f of n, right? Because it is making contact with the ramp. The ramp is exerting a contact force onto the block, so we will call that fna. Again, the A is just for block A. I'll do the same for block B. There's f of GB, and then f of GB in the y direction, f of GX again down the ramp. On this side, be pointing down the ramp, f of GBX there. And then because it is resting on a surface, there has to be a normal force acting on it, so I'll call this FNB. Keep in mind that FNB is the same as f of GBY because the net force in the y direction is 0. Likewise, on the left side, FNA is the same magnitude as f of gay because the net force in the y direction is 0, right? So we say the block or the system only moves along the surface of the ramp, which is taken to be our x-axis. Now, the next thing you should identify is the tension in the cable. Here, block B is going to move up, so I'm going to draw tension pointing up. That's what's causing block B to move up. And then, because this is just one rope, if you watch my cursor, I can take my cursor and kind of follow that line. It wraps around that pulley, it wraps around this quote-unquote free pulley, and it goes all the way up to where the attachment is. So therefore, if this is T and it's only one rope, the tension in the string has to be the same. So therefore, I want to draw T over here. Now, in case you're confused about why there are two T's over here, you have to be able to reference the pulley. Okay, the mass is attached to the pulley, but how the wire is split up between this pulley or wrapped around it is really important. You have, as this block A slides down the ramp, you have this string that's acting against it, but it just happened to be split up in two. So therefore you have T and T acting against block A's motion, while there's only one T pulling block B up. Okay. Now, the other thing you should draw out is your F of K. right? The system here is not frictionless. It's just the coefficient of kinetic friction, which imply there is friction. So if block A is going to move down the ramp on the left side, FK has to point up the ramp on this side of the system. So the arrow that came up, I'm just going to call that F of KA. And then block B is going to move up the ramp. Therefore, opposing up would be down the ramp. So the kinetic frictional force of block B is going to point down the ramp. So I'll call that FKB. Now that we have everything drawn out, all the forces, I think I got everything. Let's go ahead and set it up. So here in my work, I split up into block A and block B. So here is the important condition that I mentioned at the beginning of the video. Okay, so if you have some sort of pulley system, set this stuff up and then watch the distance. They do not move at the same rate. Okay, so here I have it. If you were to choose the perspective of block A accelerates at half the rate of block B. Or if you choose to look at this block B on the right, as I said earlier, block B will accelerate faster. It accelerates twice as fast as block A in this particular diagram. So that statement is true. It doesn't really matter here. Pick one. These two statements are both the same, right? Because if you think about it, multiplying both sides by 2 literally just tells you 2A is equal to AB, which is what I have here. So pick a perspective and stick with it. So if I want to set up the physics for block A first. So here in Newton's second law, net force of block A is equal to mass of A times the acceleration of A. Here, if you look at it, it says that block B is moving up the ramp, which implies that block A is moving down the ramp on the left side. Well, the free body diagram for block A suggests that there's an F of G AX that's pointing down the ramp, right? You have F of K A pointing up the ramp, and then you have two T's pointing up the ramps. So in this case, I have F of G AX, which is what's causing block A to accelerate downward, and then I'm going to subtract two T's because according to this pulley, I have a T there and a T there, so that's two T's. And then I have an F of K that's due to friction, which is opposing it. So I have 1, 2, 3 arrows that are acting against block A's motion. F of G AX is going to point down. So that's why these things are all subtracted. I have F of G AX minus 2T minus F of KA, which equals to MAA. And keep in mind this A here is for block A, so this is 60 kilograms in the problem, yeah? And so if I were to just expand it, FGAX is FGA sine of 60, which is right here, MG sine of 60. Okay. And then F of K by definition is just mu K times F of N. But I need to use F of N A here because this is for block A. So if you were to expand everything, I substituted out F of NA for MGA cosine of 60. So this is right here. F of GAY, which is F of N. So therefore F of NA is F of GAY, which is MG cosine of 60. But keep in mind M times G is just F of G. So here I just have F of G. It's all the same stuff. Okay. So if you plug it in, if you plug all this in your calculator, F of GA times sine of 60, you'll get 509.2 minus 2t. I don't know what t is, so I kept that as unknown. Here, mu k is given as 0.1. The weight of block A is given. So to find the weight of block A, you would just take 60 kilograms times 9.8 times cosine of 60, and then times that by 0.1, and that's how the 29.4 comes about. And then, as I said earlier, this M here is for block A, so that's 60 kilograms. So as you can see here, you have two unknowns, right? You have a T that's unknown. You have an AA that's also unknown, right? Or the acceleration of block A is also unknown. So here you can't really solve anything because you have one equation with two unknowns. Right? Therefore, as usual, that triggers that you need to set up another system of equation or another function pertaining to the same problem. So here, I want to set up the physics for block B. Net force for block B is just mass of B times the acceleration of B. And the mass of B in this case is just 40 kilograms, as stated. But if you look at block B, I see a T pulling it up, right? And then I see an F of KB acting against it. I also have a F of GX pointing down the hill. So here, there's one arrow up slope, and there are two arrows down slope. FKB, F of GB in the X direction. So I took T, I subtracted FGBX, and I subtracted FKB, and that equals to its mass times acceleration. Here, I want to isolate for t. Why? Because on the left side, I already set up the function, right? I don't have t and I don't have a. But I need to figure out what a is in order for me to figure out how fast something's moving. So I don't know what t is, so I need to figure out what t is so I can get rid of it. So when I set up the physics function on the right side, I want to isolate for t for that reason. I am going to substitute out t, right? Getting rid of t because that's what I don't know. And that'll let me find a. So here to find t, I want to move this negative fgbx and negative fkb to the right side, which makes them both positives. So the only thing I don't know here, excuse me, is t, right? So here, if you watch carefully, it looks pretty similar, but it's not, okay? Here's MAB, I just carried down. F of GBX, I broke down into FGB sine of 30, right? Because if you look at this diagram carefully, FGBX is opposite of this 30 degrees. I didn't label it. Hopefully you kept up with my explanation earlier on the left side. So the angle that touches the FGBY and F of G is also 30 degrees because the angle here over here is 30. So that's opposite, so we use sine. And then the kinetic frictional force for FKB can be broken into mu K times FNB, right? But earlier I stated that FNB, which is pointing up from the surface onto the block, is the same magnitude as F of GBY because the net force in the y direction is 0. So this dashed line that's pointing down the ramp and F of NB has to equal in magnitude. So that's a quick substitution, all right? So hopefully you're keeping up with the little details here. FK broken up into mu K FN. Well, but FN is F of GBY and everything else stays the same. So here, we pretty much have everything except for AB. But we know what AB is, right? So here, mass is 40 kilograms. I don't know what AB is. But what I can do is I can rewrite AB in terms of AA. So I heard earlier in this highlighted yellow here, I have AB, which accelerate twice as fast as block A. So 2 times A of A. So instead of AB, I substitute out AB for this true statement. That is AB accelerate twice the rate of AA. And if you punch FGB times sine of 30, you'll get 196. And then if you type in mu K, which is 0.1, times M, which is 40, times G, which is 9.8, and then times cosine of 30, you'll get 39.9, okay? So as you can see, we have here two coefficients, both are positive, so we'll just go ahead and combine like terms real quick. And this would be 229.9, so if we combine 196 and 33.9, you get 229.9. And here, 40 times 2 is just 80 kilograms times AA. But what I do notice here is that I have a T. But on this side, I have two T's. So there are different ways you can substitute T in for here. But what I want to do is I'm actually just going to solve for 2T, and I want to set the two functions equal to each other, okay? So I notice here on the left side, I have a T. I notice on the right side, I have 2T. So what I want to do is I want to move this negative 2T to the right side of the equal sign, which makes it positive. But at the same time, to get it by itself, I need to get rid of this 60AA. Well, I want to move it to the left side, which makes it negative. So here, the 509.2 I just carry down. The negative 2T, I move to the right. The negative 29.4, I carry it down. The 60AA, I move it to the left side of the equal sign, which makes it negative. So here, you have two coefficients. I can combine those two, and then just simplify the function. So 509.2 minus 29.4 will give you 479.8 minus 60 AA, and that equals to 2T. But this is 2T. This is only T. So this is one trick you can do. I can just multiply the right function by a 2. Why? Because the left side is 2T. So I can make the right side also 2T by simply multiplying the whole entire thing by 2. So if I'm multiplying the left side equal sign here by 2, which I have highlighted there, you need to do the right side as well. So 80 times 2 is 160, and then 229.9 times 2 is 459.8. Okay, so keep in mind to do your algebra properly, you have to multiply both sides by 2. All right, now that I have two T's and two T's, I'm just going to set the two statements equal. So I'm going to set 479.8 minus 60AA, which is on the left side here. Here I just left out the units just to clean up a little bit. That equals 2T. But the right side here is just 160AA, right, plus 459.8. So I carry both statements down. I set them equal. So as you can see here, the only unknown now is AA, which is the block on the left side, right? Because it asks us to find the instantaneous speed of block A. So I need to find what AA is, which I have here. So to combine like terms, I'm going to move the negative 60 AA to the right side, which makes it positive. And I'm going to move this 459.8 to the left side, which makes it negative. So here, that's what I did. And then combine like term, 160A plus 60A, that's going to give us 220AA. And then 479.8 minus 459.8, the difference there would just be 20. And then to solve for A, divide both sides by 220. So if you take 20 divided by 220, you'll get 0.09 about. So here's the acceleration of block A, right? Well, the question didn't ask you to find the acceleration. It asked you to find the instantaneous speed of block A after block B has moved up 2 meters. So I'm going to go back to common form. The kinematics function that allows me to solve for V without knowing time is this one right here. What I'm going to do though is I'm going to cross out VI because it says starts from rest. So block A starts from rest. And then I'm just going to plug values in here. I know what VF square is equal to 2A delta X. So therefore to get VF by itself, I would just radical both sides. Well, 2 I carry down. The acceleration of block A I just found as 0.09. But what I do want to point out is this delta X right here. I highlight it because it's super important, okay? As I stated earlier, they have different acceleration. Block B accelerates twice as fast, suggesting that block A accelerates half as fast. In the same amount of time, if block B moves up 2 meters, well, because block A accelerates slower, it actually only covers half the distance. So this is a 2-to-1 ratio that's very consistent. So it's important that you plug in 1 here. It's a common misconception that kids often plug in 2 because the statement says 2. And that's a big trap layout for you, right? Just because block B moves up 2 meters doesn't mean block A moves down 2 meters. It actually only moves down 1 meter because it accelerates at half the rate. So I made a note here. This is super important because it would suck for you to do all this work and then get to the last step here and then plug in 2 meters, which is not, right? Block A only goes down 1 meter because it accelerates slower. So once you have that established, really the rest of the work is stupid, okay? Just plug it in, take the square root, and for this particular problem, your final speed is going to be 0.42 meters per second, and it says speed, so I don't need to include any sort of direction. All right, I hope that helps. Make sure you understand these ratios between A and B, and once you have that, hopefully algebra carries you through. All right, stay nerdy, don't be whack. Good luck.